Hello and welcome to another ramble with me. We are looking at question 8b from IEB's paper 1 November 2022. In the diagram below, a ball bounces indefinitely, I love it, along the path modeled below. The ball starts at A, where it is catapulted into the air before bouncing for the first time at B. The horizontal distance BC is 3/4 of AB. Whoa, okay. So if this was 4, this will be 3. And CD is 3/4 of BC. Okay, so CD would be 3/4 of 3. Okay, cool. So if this started out as 16, this would be 12, this would be 9, and the pattern continues indefinitely. So this would be 3/4, well, plump. That distance would be 3/4 of CD. Okay, cool, got it. Each bounce is modeled by the equation y is equal to minus a half x minus p squared plus q. Okie dokie. If the ball continued to bounce, it would eventually converge with the horizontal 16 meters from point A. Interesting. Converge is such an interesting word because converge makes me feel like it would just roll after the 16. But technically, if the pattern is continuing indefinitely, it wouldn't just be rolling, it would just be very small, indiscernible bounces. Is that what rolling really is? This is where the physics people need to come in. Okay. But yeah, this is giving sum to infinity, right? That, yeah, when you add, so we're dealing with the, if we're looking at the horizontal distances and what they add up to, we are dealing with a geometric series where the r is 3/4 because, yeah, each distance is 3/4 of the previous one. And so because the 3/4 is between -1 and 1, that means our geometric series does converge. So this information over here is telling us what it converges to. And because we have the r, that means we can work out the a, as in the size of the first horizontal leap. Right, and that is in fact the first task. So we've been told that the sum to infinity for the horizontal distance is 16 meters, and the r is 3/4, and now we're going to work out the a. So using the formula, that is equal to this. That we've been told is 16, and that we know is 3/4. So we have 16 is equal to a over a quarter. 16 is equal to 4a, therefore a is equal to 16 over 4, which is 4. Right, so that is the length of that first horizontal distance is 4 meters, right, is what we're dealing with. Does anyone ever say, oh, based on this? Right. Okay, so that is that first answer. Second one says, what is the maximum height reached by the ball between points B and C? Okay, so we're looking for the turning point of this parabola. So we need to know its equation, right? We've been told that, yeah, we have that. So we just need to figure out these two, which we can do because, I mean, if we treat this as the origin, we now know that B, the x-coordinate of B is 4, and then BC is going to be 3/4 of 4 meters, so this is going to be 3 meters. So the x-coordinate of C is going to be 7, right? So then we can use our intercept what? But yeah, that form of a quadratic quadratic function to then eventually rewrite it in this way, maybe. Yeah, I'm just gonna do completing the square for fun, but technically we could also just, once we have it looking like this, we could use our formula that says, that this is the x-coordinate of the turning point, and then find the y-coordinate of the turning point, and then we're good. But just because I miss completing the square, I'll complete the square. Anyway, so let's write this all down. So the coordinates of A are 0, 0. The coordinates of B are 4, 0. BC is 3/4 of AB, which is 3/4 of 4. And that is equal to 3 meters, right? And therefore the coordinates of C are going to be 4 plus 3, 0, which is 7 and 0, right? So that means that the equation for second parabola will be y is equal to, we know the A is minus a half, we've been given that over here, right? Then we know that, okay, the x-intercepts for this parabola are 7 and 4, so it's going to be x minus 4 in the one bracket, x minus 7 in the other. I'm going to multiply them out. Right. Okay, and then let's complete the square. So it'll be 121 over 4. Let's put this over 4 as well. 56 times 2. Wrong bracket. Okay. Right. So this is minus 121 plus 112, so that's negative 9 over 4. And then if we multiply the minus a half in, we get positive 9 over 8. Okay, so this, okay, let me just copy this so that we have it as a reference back where we are going. Okay, so what this is telling us is the equation for, so y is equal to this is the equation for this parabola over here, right? So it's a parabola that is downward facing, concave down, relative to the parabola that goes through the origin. So kind of the original parabola that is downward facing would look like that. So relative to that parabola, it has moved to the right by 11 over 2 units, or 5 over 2 units, and then it's moved up by 9 over 8 units, right? So that is what that is telling us. Cool, so what was the question? What is the maximum height reached by it? Okay, so that'll be the 9 over 8. Right, so therefore turning point is, alright, so max height between B and C is 9/8 meters, so 1/8. Memo, show me what you get. What question are we even looking at? Question 8b. So we agree. Oh, so what they just did is, and that's actually even faster, is to find the midpoint between, midpoint, I'm using this word wrong, but the halfway between 4 and 7, right, which is 5.5. And then from there, then they got the equation of the parabola this way and just put in the 5.5 in there and got the y coordinates. So definitely a lot faster, but anyway, no rugrats because completing the square is fun. Cool, that's it for this question. See you another time for another ramble.